summation down here. Nathan, you got that for us?
So this is like exactly how our grades are weighted too,
Yes.
right?
Well, no, I mean, the percents aren't exact, but the process, yes.
Right, process.
Because I do formative and summative. I believe I do 85% for this class, or maybe no, I think it's 80%. 80%, I think, for summative and 20% for formative. Maybe it's 10.
88.6.
88.6. Okay, so about what we were expecting. This person got a high B plus, or an AB. Does that make sense to you guys? Okay. Now, officially the formula is this, so everybody write it down. This fancy symbol is called, this is very funny. Anybody have an idea what that's called? Think of the dumbest thing you could say for it.
X with a line over it.
It's called X bar. Yeah. Here's a really funny one. Later, we're gonna do this one. What do you think that one's called? This one's called P-hat. And it's spelled like fat, like P-H-A-T, fat. Yeah, P-hat. Mathematicians, right? Really cool. All right, this is called X bar, and this is a symbol for sample mean. So the formula for this is the summation of all of your x times w's, and then you divide by the summation of the w's. Now, we didn't divide by any summation of the w's. Can you guess why? What do you think it would have been if we had added all of these up? 1. And if I divide by 1, I still get 1. So on this one, especially anytime you're doing like a grade, hopefully these percentages already add up to 100% or 1. So you wouldn't have to divide by anything. But occasionally you'd have to divide by the summation of the w's. How do you feel about this? Not too difficult? And yes, this is exactly how your grades are calculated. So remember when I told you that during my calculus test, instead of studying for calculus, I created a program in my calculator that calculated exactly what everybody would have to get on their final exam to get certain grades. And then I had people, like, I passed my calculator around, and we all, like, used my program to see what grade they would have to get by using a weighted mean. Because I was a big old nerd, but not a big old nerd doing their job, studying for what they should be studying for. Instead, I studied for something else, which is apparently statistics. Okay, the last thing we're doing is we're drawing some pictures at the bottom. You're gonna draw 4 pictures, so we're gonna go real fast at this. Just make like some axes like we're making graphs. These are not gonna be perfect pictures, so Nathan, don't lose your mind. The first distribution we're going to sketch looks like this. There's a whole bunch of like bars, but some of them are slightly taller, slightly shorter than others, pretty close though. This is called a uniform distribution. Anybody want to guess what the word uniform means in this case? And it doesn't mean outfit. In a line, all the same, uniform. A perfect uniform distribution would have them all exactly flat, but realistically, they might be a little higher or lower. For example, let's say that you looked at colors of M&Ms. Hopefully in a bag, if we had a whole bunch of colors for M&Ms, you would have about the same number of red, about the same number of green, about the same number of blue, but you might have one that's a little higher, one that's a little lower, but they're about uniform. Next one is called symmetric. Anybody want to take a guess what that one looks like?
2 pillars.
Okay, so what you're thinking of is it's kind of like a mirror.
Yeah.
And that is exactly right, except for it doesn't look like 2 pillars. It looks like a bell curve, where like the middle is the highest. It doesn't have to be exactly the same on both sides, but pretty darn close. But when Noah says it looks like a mirror is down the middle, he's exactly right. It just looks kind of like a hill. Anybody think of a good example of something that could be symmetric? Maybe like IQs. We got most of the people sitting here in the middle.
Test scores.
Test scores, sure. Actually kind of depends. Sometimes you could have, if you had a really hard test, yeah, I'd say it'd be symmetric. But like I'm shooting for, like when I teach you guys, I'm hoping that most of you get A's and B's. I'm hoping that I'm not like, okay, one of you has to have an F, only one person gets an A, most people get C's. Although when I was teaching in college, that is exactly, not teaching in college, when I was going to college, that is exactly how they did the grades in the psychology department. They took your entire class, which in my case, it was just like Psychology 101. So it was like 300 people. And they figured out exactly the Bell distribution and exactly what percent of people got A's and what percent of people got F's and B's and C's and D's. So only 2.5% of our class could fail, and only 2.5% of our class could get A's. So I got an AB in that course with a 95%, because 2.5% of people were better than me. So I hit the AB category instead, which was very annoying, and I hated it. But so it would be like awesome if you're the kind of person who would normally fail a course, because you just have to do better than 2.5% of the bottom people. But anyway, it's called symmetric. Next one is skewed left. This also looks like a bell curve, except for the bell part is kind of on one side, and then you've got like a tail that leads off in this direction. This is also called left-tailed. Left-tailed or skewed left. You think an example for this one where most people would be here up the upper range, but you got a couple people dragging off the side?
Say like average end time of the school day.
Oh, that's a good idea. So maybe when you leave school?
Yeah.
So most people are leaving school at the end of the day. Some people are staying late, right?